Hello, my name is Noemi Gavazzi, and I worked alongside Professor Parziali and my partners Jack and Jaden on the Helmholtz resonance tube that's put inside of our Stevens wind tunnel. Now, the main idea as to why we came up with the resonance tube was we wanted to read the speed of sound inside the reservoir of the tunnel, just to gain an understanding of how the flow is moving and the thermodynamics of the flow, just to make sure that we could ensure everything is working correctly and see if we can make anything more efficient or run any new tests. So just to get an understanding of where this goes, the resonance tube goes inside of a donut that's inside of the reservoir. It's this like sky blue, the darker blue inside the reservoir pressure probe. As you could see on the left, it's an example of our whole entire wind tunnel. The donut goes inside of there, and we just kind of screw the resonance tube in. And there's a sensor inside the donut on the end where we could read the speed of sound within the tunnel. So we actually attempted two other things before we got to the resonance tube. We attempted an ultrasonic sensor circuit. So for this, we made a transmitter circuit as well as a receiver circuit. And the whole idea was we wanted to use these ultrasonic sensors and read the speed of sound inside of the tunnel. And we would put them inside of the donut and see if it could read the speed of sound. The issue with this was we found out that the ultrasonic sensors might not actually be able to read the speed of sound within the tunnel due to they might break because of the excessive heat that they may endure, because there is a certain tolerance that the sensors could work up to. So we didn't think it would work inside of the tunnel, and we did some testing and decided it wasn't the most efficient way and we could find something better to do. So we also tried using a thermocouple wire, and within this wire, the whole idea is that there are two connections, two thin wires that are meant to be connected at a joint, which is one singular point. So we tried soldering the end to make a singular point, but it had to be really small, really microscopic, and very hard for us to do. So eventually we realized that it wasn't actually working correctly. The connection was lost, and that joint was not connecting properly due to the solder being too big. So we decided using a resonance tube instead. So to the bottom right, you could see we tested a couple different designs on ANSYS, which my partners will talk about shortly. And the whole idea is we have through holes with the straight beams. There's three different kinds here on the bottom. And a through hole is a hole from the top and the bottom, and they're parallel to each other in a complete line. So we tested that at the front, back, and middle of that tube. And we also tested a bent tube that's completely intact and one with a whole assortment of different kinds of holes. And we tested it on the simulation ANSYS, which gives us a better understanding of how the resonance tube would act inside of the wind tunnel before we actually put it inside, and make sure that it is safe to test and make sure that it is efficient. So my partners will go into that shortly. Thank you so much.